Artificial intelligence encompasses a spectrum of technologies that mimic human cognitive functions with varying levels of sophistication. Large language models, or LLMs, such as GPT-4 and Claude, can generate human-like text, translate languages, write different kinds of content, and answer questions in an informative way. Multimodal AI systems integrate text with image, audio, and video understanding, enabling them to describe visual content, generate imagery from textual descriptions, and even create music or edit videos based on natural language instructions. Reinforcement learning with human feedback allows these systems to be fine-tuned based on human preferences, improving their ability to follow instructions and align with human values. Meanwhile, agent-based AI architectures can plan sequences of actions, use tools such as calculators or web browsers, and solve complex problems through chains of reasoning. The current reality of AI reveals both remarkable capabilities and significant limitations. Today's AI systems excel at generating content, providing information, and performing pattern recognition tasks, but they lack robust understanding of the world. They suffer from hallucinations, confidently stating incorrect information, and struggle with tasks requiring common sense reasoning or causal understanding. LLMs remain constrained by their training data, exhibiting whatever patterns and tendencies were present in that data, and unable to access real-time information without additional tools. The computational resources required to train and run these models creates environmental concerns, with the largest models consuming substantial energy. Present AI deployments primarily augment human capabilities rather than replace them entirely, serving as co-pilots in creative work, research, customer service, and educational settings. In the near future, AI could develop capabilities that fundamentally reshape human-computer interaction and expand the boundary of automation. Hypothetical systems might achieve robust reasoning capabilities, enabling them to perform scientific research by designing experiments, generating hypotheses, and interpreting results with minimal human oversight. Personalized AI tutors could dynamically adapt to individual learning styles, providing customized education at scale. In governance, AI systems might help model complex policy outcomes, simulating the environmental and social impacts of different approaches to climate change mitigation. These speculative applications would require significant advances in reliability, interpretability, and alignment with human values, challenges that remain unsolved in current AI research. AI applications in social and biological contexts create new possibilities for understanding complex systems and addressing persistent challenges. Machine learning models analyze genetic sequences to predict protein structures and functions, accelerating discoveries in medicine and biotechnology without requiring exhaustive laboratory testing. Environmental monitoring platforms integrate satellite imagery, sensor networks, and historical data to track ecosystem changes, detect illegal deforestation, and predict wildlife movement patterns. Natural language processing enables analysis of scientific literature at scales impossible for individual researchers, identifying emerging connections across disciplines, and surfacing relevant research from obscure sources. Healthcare AI assists medical professionals in diagnostic imaging, treatment planning, and resource allocation, extending expertise to underserved regions. The current deployment of AI in these domains demonstrates both promise and limitations. Healthcare applications show impressive diagnostic accuracy for specific conditions, but struggle with generalization across varied populations and integration into clinical workflows. Environmental monitoring systems successfully track certain variables, but face challenges in coordinating heterogeneous data sources and translating insights into effective interventions. Educational applications provide personalized learning pathways, but often fail to address deeper questions of engagement, motivation, and holistic development. These implementations typically complement, rather than replace, human expertise, augmenting capabilities in data processing and pattern recognition, while relying on human judgment for context, ethical considerations, and complex decision-making that crosses domain boundaries.